Hello, Science 9. Today we are going to be talking about acids and bases. So, what are we learning? Well, today we are learning to identify an acid and a base and its pH. You can tell that you've learned this by explaining qualities of acids and where its pH falls. You can identify bases and its pH. You can explain what an indicator is. You can tell me what a litmus paper is and how it reacts to acids and bases, and what the term neutral means in regards to acid and base. So to start our day, we're going to do a little activity of guess what you know. And there's a chart that you have in your notes in which it says you make your initial guess. So I want you to pause this video right now and make a guess on what all of these different substances are. Now that you've made your guesses, we're going to go through and we're going to talk about each one. So the very first thing that we need to know is an acid is kind of got this tart, sour taste to it, a tangy taste. So anything that is tart or tangy is going to fall under the world of acids. So that would be things like our carbonated beverages. Coca-Cola, like Coke the can, is a very acidic drink, and too much can actually wear away the enamel and do some damage to your insides. Celery is a base, which again, how do you know? We'll talk about that. Radishes fall towards the acid end. Tang, remember how I said tart and tangy can mean acid? So the tang of salad dressing would be acid. When your muscles burn after a good workout, that's due to lactic acid buildup, so that's an acid. And then second last but not least, you have the sunburn lotion. So aloe vera is actually a base, and slippery soap, try saying that 10 times. Slippery soap is actually a base. So how do we know? Well, first thing is when it comes to food, we can say acids taste sour, like think of biting into a lemon, where bases taste bitter. Now, here's where we kind of run into a problem. In the lab, we wouldn't send you in there and say, here, taste an unknown chemical and tell us how it tastes. That'd be very dangerous. You don't know how dangerous it is. It could be extremely acidic. It could burn you. So you don't ever taste anything in the chemistry lab. Same with how they feel. A base feels very slippery. We're never going to send you into a lab and ask you to touch an unknown substance. You don't know how dangerous it is. It could be corrosive and it could burn you. So in the lab, we actually have to use chemical indicators. And what we're doing is we're looking for noticeable color changes when we are going through and trying to determine if something is an acid or base. Some of the common ones we use are phenolphthalein and bromothiamine blue, and then litmus paper. Phenolphthalein in the presence of an acid stays clear, but in the presence of a base turns a very bright pink. And with bromothiamine blue, it stays blue. And then in the presence of an acid will turn yellow. So here we have acids or bases. And we're going to go through, again, you have a chart that you can just fill in. These are common household items you may find around your house that you may not know if they're an acid or a base. So bleach is sodium hypochlorite. And because it has the chlorine with it, it's making it a base. Laundry detergent is ammonia, so it is a base. Drain cleaner, also a base. So these are three very, very basic and dangerous products at your house. So don't touch them without gloves or proper cleaning supplies. Milk actually has lactic acid in it, so it tests more towards an acid. Soap is also a base. Window cleaner, a base. An antacid is neutralizing an acid, so it is a base. Vinegar, which you may use in your cooking, is known as acetic acid. And orange juice, which you can drink, has citric acid in it, so it is also an acid. So again, these are just common things around the house you may have seen that now you know are acid or a base. But again, how do we know for sure? I'm telling you this, but what are some of the ways we can actually test for it? One of the ways you can test for it is with litmus paper. So litmus paper is something that we use that is both comes in the color red and blue, and it comes from a compound made out of lichens. When you bring litmus paper into contact with an acid, it will turn red. So if you look up here, here's what red litmus paper looks like. If I was to dunk this into an acid, it would stay red. If I were to dunk this blue litmus paper into an acid, it would turn red. All right, so in the presence of an acid, your litmus paper turns red. In the presence of a base, if I was to dip this blue litmus paper into it, it would stay blue. If I was to dip the red litmus paper into a base, it would turn blue. So again, bases are blue. So this gives us an approximation. Again, if I had two unknown liquids, both clear, I didn't know what they were, and I dipped my litmus paper in, if one turned red, that would be an acid. If one turned blue, that would be a base. But the problem is, I don't know how dangerous they are. They could be really close to neutral, which is 7, which we're going to talk about in a second, or they could be a 14 or a 1, which is extremely dangerous in the world of acids and bases. So we have to have something that helps us understand pH. What is pH? So this is the pH scale. The pH scale is measured from 1 to 14. So you can see it along the bottom here. 0 to 7, okay? This is your acids, and then you hit neutral. From 7, which is neutral, 8 to 14 is base. So you can see here's my drain cleaner that we talked about earlier. It's a base and its pH is 14, the strongest that you can get, which is kind of dangerous. Here's ammonia, which you can find in your laundry detergent, okay? Again, falls somewhere between 11 and 12. Here's your soap at about 10. It's a little safer. And then down here, we have different common foods and whatnot. So what is the pH scale? Well, the pH scale determines the strength and concentration of an acid and a base. So a strong acid will react with water to make hydronium ions, and a strong base will react with water to make hydroxide ions. Now, this is important to understand because when they dissociate in water, it also allows them to react with electrical conductivity, meaning it will be able to conduct electricity. So what we can do is if it's a stronger acid, you will get a better reaction for the electrical current. You can measure that current using something called a pH meter. In Science 9, we don't use those. Instead, we use something called universal indicators or pH paper. Essentially, what you do is you take a little strip of paper, much like the litmus paper, you dip it in your unknown substance, and then you look and you measure it along a scale to see what it looks like. I have a video later that will go through and show you what that looks like. So here I have a little video to show you the different changes of colors from acids to bases. So what we're going to look at here is this person has a very strong, it says here, universal solution, and then you can't see this yet. Oh, sorry, guys. But this says pH of 14, so that's a very strong base. So they're going to slowly add an acid into this to hopefully get it to change color, moving it towards the acidic end of the pH scale. So the more acid they add, the more color it's going to change as it moves from a pH of 14 hopefully down to a pH of somewhere along the 1. So now you can see that that blue level is actually a little bit less of a base than the purple, and that's why you're getting that color change. So the purple is a 14, the blue might be a 12. When you see that red color, and then it's moving back to its original colors, we call this neutralization. When you add a base and an acid together, as it moves towards that yellow color, it's neutralizing. It's becoming a pH of 7. So now you can see that we have taken it from that base of 14 and we've brought it down to a neutralized color, okay? Universal indicator, all right? So you can now see that the pH has changed. The red color is going to be more acidic. The yellow color is going to be more of a neutral color. So that is it for acids and bases. Please make sure that you have it in your notes. There's going to be another video that's a demo showing you about acids and bases. And then there's a online activity that you are going to do to work with acids and bases. If you have any questions, please let me know.